Alrighty, hello everyone. Welcome to Lowell Observatory. And also this is part of the Grand Canyon Star Party, so we're super excited to have this awesome opportunity to do a nice long live stream for you guys. My name is Claire. I'm an educator here at Lowell Observatory, and I have an awesome co-host with me, and I'll let them introduce themselves.
Yeah, hi, I'm Jose, and I'm also an educator at Lowell Observatory. And yeah, we have going on right now. We have this little blue circle in the camera right now, and this is called. It's got lots of names, but most commonly known as the Blue Racquetball Nebula.
Yeah,
And
for the catalog name is also NGC 6572. So if you guys are kind of trying to look it up on your own, that's the catalog number that you might be able to find it a little easier with. But this is an awesome planetary nebula. So this is a dead star in the night sky. And this one's particularly cool because it's a really young one, which means that it's going to be particularly bright. So this is a great one that you can go out and grab with a nice telescope or even a pretty small one. So that's kind of cool. But we wanted to announce that there's kind of an interesting debate going on with this one about what color you guys think it is. So I personally think this nebula looks blue, but some other people think it's a different color. So
yeah, I definitely think that it looks more green than blue. So if you want to leave what you think in the chat, what color you think it is, maybe we'll find out once and for all what color it really is. Some of the other nicknames this planetary nebula has are the Emerald Nebula and the Green Nebula. So even astronomers apparently can't seem to decide.
Yeah, I feel like the blue team is kind of losing, but oh well, we'll see what happens. Put it in the chat. We're excited to see that. But we figured we'd just start out with this one because it's a nice, cool one to start us off with. And for some of you guys who may be new to Lowell Observatory's Interactive Stargazing, what we're doing is we're using our MallinCam telescope. It's a 14-inch plane wave telescope, and we have a MallinCam camera attached to it. So we're taking live views of all of the stuff that we'll be looking at tonight in the night sky. And your guys' job is to give us cool objects to look at. So as you might have already seen, other people are putting things in the chat for things that they want to look at. So if you have an object, go ahead and input it in the chat, and then we'll try to get to that object when we can. There is one stipulation. How the building works at the Giovanni Open Deck Observatory. Some areas in the north are a little bit hard to get just because the actual building itself is in the way, but we'll let you know if that happens, and we'll let you know if there's some reason that we can't see an object, but put them all out there and we'll do the best that we can. So I think we can go ahead and start moving to the next object that we have requested, and it's from Gerard Joseph for his Deep Sky fave, M13. I totally agree with that. This is one of my favorite objects. M13 is the Great Hercules cluster, and it's a globular cluster. And I'm excited to look at this one. So yeah. So what we're doing here, what you just saw is our MallinCam or our plane wave software. That's how we actually control the telescope. And what you're seeing now in front of your screen is our MallinCam software, which is how we manipulate how the camera is working. We can change how sensitive the camera is. We can change the amount of exposure time for brighter or less bright objects. And then eventually we'll get the correct settings so that we can get an awesome image for you guys. So again, we're looking at M13 right now, which is a nice big globular cluster in the night sky.
Yeah, so this globular cluster I know is definitely like a fan favorite. Like this one's one of the brightest globular clusters, and it's up during the entire summer, which is exciting. This one's about 25,000 light years away and probably contains about 250,000 stars. Now you can tell that it's really, really dense. And that's because the relative size of this whole cluster, all of these stars are contained probably, and Claire, you can correct me if you know the exact number for this, but these are contained within like a very small radius of probably less than 100 light years. And to put things into even more perspective, the nearest star to our sun is 4 light years away. And in that distance, for stars in this cluster, you're going to have, probably tenfold more stars in between. So you're not going to get any nighttime pretty much if you're on a planet around one of these stars here.
Yeah, that's super cool. One of my favorite things about these objects is just whenever guests come up and look at them through the telescope, they're always startlingly bright, and they sometimes people say that they look like other really cool things. Like I've heard frozen firework or like a glittery dandelion, which just sounds really cool, or like raindrops on a spider's web or something like that. And I think those are all really good descriptions of what we're looking at here. Globular clusters, there's a lot of them in the night sky, so they're always cool to see.
Yeah. So we have a few more requests coming in, and our Sherrard has requested the Crab Nebula, and that one is unfortunately a winter object. You can see it at its highest probably in the dead of winter, and so we're not going to be able to catch the Crab Nebula for a couple months. And then Joseph Fragola has also requested a planetary nebula in Lynx called the Headphone Nebula. But the unfortunate thing is it's behind some trees for us, so we're not able to get that one either. So the next one we're going to go on to Tom Sarko's request, which is M57 or Messier 57, which is the Ring Nebula. And we were actually just looking at the Ring Nebula right before we started this stream. We really like this one. This one's another fan favorite here because it does have that typical ring shape. This is a planetary nebula, so this is similar to what we were looking at before was the blue racquetball. This one's a little bit brighter and has a little bit more closer, so we get a little bit more like you can see it looks bigger. But you can see at the very center, there's actually a little star. That's the white dwarf. That's the dying core of this star that it used to be part of.
Yeah. And how I like to describe this object when we look at it through telescopes, specifically with our own eyes, it kind of looks like a fuzzy Fruit Loop in the night sky. And I think it's a great description for it because it does. It kind of looks like a fuzzy Fruit Loop or like maybe a blueberry donut or something like that. And it's just, most planetary nebulas, we usually can't see such like a clear ring structure with this. And I think this is what makes this one so exciting to look at, especially because it's so close to us. It's only about 1,400 light years away, which is relatively close for an object of this type. And it just has really awesome structure. And we can usually, with this one, resolve that white dwarf star in the middle, like Jose was talking about, probably the best out of most of the planetary nebulas that we look at in the night sky, which is pretty cool. And I just love how there's different colors too. So you can kind of see on the edge, it might look a little more red or orange. And then towards the inside, it gets a little more blue and a little bit more green. And those colors can tell us what this star was made out of when it was actually alive. So we know that some of that red stuff is probably going to be on the end of hydrogen and helium, and then some of that blue turquoise stuff might be more towards the carbon end of the periodic table. So we can kind of like reverse engineer our way to what the star was like when it was actually alive, which is pretty cool just by looking at the color of it. And that's kind of the beauty of colors in the night sky, is we can do that type of thing. So yeah.
Another thing about the planetary nebulae, the other one that we were looking at, the blue racquetball, is a lot younger than this one too, because it hasn't had a lot of time for all the gas to kind of spread out. So all that gas is actually spreading out because of the stellar wind. And so this one is going to be a little bit bigger as well. It's been around for a while. So the gas is it's going to be bigger in size in general. And the neat thing about this is the gas is entirely temporary. It's going to spread out so far we can't even see it anymore. But that white dwarfs, they kind of stick around for a really long time.
Yeah, they'll last probably trillions of years, which is way beyond my time. So so I think we can go to another object. I know we have lots popping in, so we want to try to get to as many as possible. It looks like we're going to go to another planetary nebula that Studio McGraw has requested, NGC 6210 or 6210 in Hercules. That's pretty cool. I don't think I've ever seen this one before. So I'm excited to see what this is. It looks like it's a magnitude 8.8, so that should be well within our reach. And just as another comment, I just saw this in the first time in my from Seattle in my 8-inch telescope under light polluted skies, and would love to see it here. Well, hopefully we'll get a much better view than what you could see in Seattle, because we have beautiful dark skies here in Flagstaff. So that one looks nice. It's a nice blue little ball in the night sky.
Right now, I'm just impressed you can see that from Seattle, considering like how much light pollution you guys get in the city there. Here in Flagstaff, we're an international dark sky city, so we have very, very little light pollution that's noticeable. So we can even see like the Milky Way and in the middle of the city. It's kind of cool.
Yeah, sometimes when guests have like not been able to see the Milky Way, perhaps for their whole lives potentially, and they look up at the night sky when they come here sometimes, and they're like, what's that cloud coming across the sky? And we're like, it's the Milky Way actually. So it's always fun to say that. But yeah, this looks like just another really nice planetary nebula in the night sky, and one that's in Hercules, which is in a pretty good position in the night sky right now. It's it'll last for quite a while. It's one of the best spring constellations. Oh my gosh, kind of blinked right there. But that was kind of a nice one to look at. It looks like this one's a little more blue, which is, I think that's cool.
I will agree with you that this one is in fact blue.
Sounds good. So let's go ahead and move on to the next one. It looks like the next one we have is from Marty Breeden, M82 or Bode's Galaxy or Bode's Nebula. So we're going to try it. There's a small possibility that it might be behind the Godot building, but let's at least try it. I have high hopes. So M82 looks like that's the one we're trying to go to. So I believe M82 is also known as the Cigar Galaxy. And it's named because of that, because it kind of looks like a glowing cigar in the night sky, and it's one of the brightest galaxies that we can see here on our vantage point on Earth, which is pretty cool. So I believe it is the Cigar Galaxy. We're just manipulating the camera a little bit to be able to get a nice exposure of that so we can see some detail of the actual galaxy itself. Nice, that looks pretty good. And so this one is something that we call an irregular starburst galaxy. And it's weird because I feel like astronomers are really fixated on naming things in the night sky after candy. So this is a starburst galaxy. But really the reason why it's named a starburst galaxy is because it has an abnormal or just a lot of stars being formed in the galaxy right now, like more than we would usually think would happen in a galaxy like that. So it's just manufacturing so many stars, and that's why it kind of gets that unusual shape and also that unusual brightness right in the center, which is pretty cool.
Yeah, so the thing is with this one is it's also interacting with another galaxy, and that could be one of the reasons why this star formation kind of was just suddenly triggered as well. And that other galaxy is also called the Bode's Galaxy, which is incidentally M81. So
yeah, that's kind of a cool interaction. Even in the middle, you can kind of see how that galaxy almost looks like it's cut in half. And we think that structure is actually part of that past interaction with the other galaxy. So we can see physical evidence of this, what we're looking at right here, which is pretty awesome. And I just want to remind you guys that what we're doing here with this camera and with our technology is that we're showing you a live view. So currently it looks like we're taking about a 15-second exposure. So this is a fresh new 15-second photograph for you guys. So we're not just pulling up old pictures on our computer. We're taking these right now, right here for you guys as you request them. So this is a pretty cool thing that we're doing. But I think we can go ahead and move on because I know we have lots of requests to get through. So we had one from Joseph Fragola again for the Ghost of Jupiter. So right now it has set too far below the trees for us to see. So I don't think we'll be able to get that tonight, but let's see if there's another one to look at the new Draconis, the double star in Draco, I believe. That's what we're looking at. We might be able to get it. It also might be obstructed. Let's see. It's kind of near Vega, which is hopefully a good sign for us. Usually we can grab things in there. So what we're doing with this, since it's with the normal catalog that we're using, that object doesn't come up. We're doing a specific online search for it using the PlaneWave software so that we can find that object a little bit easier. So it might just take us a couple more seconds to get that through just because it's an unfamiliar object for us, but it's not a bad thing. So yeah, so this is a double star in the constellation of Draco, I believe.
Yeah. So it looks like the stars, that to me, they look identical in the picture, which is nice. They're very similar to each other. Sometimes we have stars that are two different colors, and these ones look like they're just about the same. So color in stars tells us a lot. It tells us about the temperature specifically, although some other factors could play into how red or blue a star might appear as well. So these stars, to me, they have a bluish tint to them. They're not entirely like perfectly white for me. So that would mean that they're going to be hot stars. Stars that are blue tend to run between 20 and 60,000 Kelvin, or 20 and 60,000 degrees Celsius, which is incredibly hot. And if you compare the sun, which is about 6,000 Kelvin, which is a cool star. So these are actually white class A main sequence stars. So these are really blue stars. We have this mnemonic that we use to classify stars by temperature. We have O, B, A, F, G, K, and M, and O is the bluest and the hottest stars, and M is it's the coolest and the redder stars. So these ones they're on the blue side of the spectrum, but they're kind of like just barely on the blue side as well.
Nice. That's kind of cool. Yeah, I've never seen this. Oh, I've never looked at this specific double star, at least.
And these are actually about.
Oh no,
these
go ahead.
are actually about 7,000 Kelvin, so they're just a little bit more than like 7,000 degrees Celsius. So Kelvin and Celsius only differ by 273 degrees. So when it comes to hot temperatures like this, they're basically the same at this point.
That's a fair assumption. Flashbacks to chemistry doing the calculations for gas laws. Let's go ahead and try another object. So we had another request to look at Planet X or Planet 9 tonight, so we won't be able to get that. So let's try a different one.
They're talking about Pluto, which was the original Planet X.
True.
That's in Sagittarius. And no, that's too low. That's
still too low for us if that's what was meant.
The only thing they could possibly mean is
Lowell,
we discovered Pluto 91 years ago. So
nice. Back in 1930. So we have a request from Sky Guy. How about M51 and NGC 4565? Let's go to M51 first. If that's I think maybe it's the same one. Let's see. So M51, I believe, is the Whirlpool galaxy. And this is probably one of the most exciting things to look at in the night sky currently, because it's just an amazing galaxy. And we'll see that in like 5 seconds. Once that exposure comes through. Nice. Sweet. So this is part of the Messier catalog, again, M51. And this is a really cool galaxy because it clearly shows galaxy interaction. Or an even exciting term to use for this is called galactic cannibalism, which is just totally an awesome term in astronomy. But what's happening is that you see that big galaxy kind of on the left side of those two. That big galaxy is slowly eating that tiny little one kind of on the top right. Then you can even see they're connected by this like line of gas. And again, that big galaxy is just sucking material into it. So this process usually takes millions of years to occur just because galaxies are so big and massive. We're talking about basically like the largest scale of bigness in the sky, basically. And so this process will take a long time, but we can look at different galaxies and stuff like that and understand how this process works. And this is one of the best and brightest in the night sky for actually showing this process, which is pretty cool. Yeah, that's my tidbit.
We can go over to 4565 now, and we can look at this galaxy. We were just looking at it right before we started the stream.
Oh yeah, okay, that rings a bell now.
Yeah, this is I think, what did you say it was called? The Needle Galaxy. And so this one's we, very similarly to that cigar galaxy, we're looking at a galaxy that's a disc shape, but it's edge on. So if like a galaxy is like a plate, and whirlpool, we're looking down at our dinner, but now we're looking from the side of the plate here. And so you're going to see it's going to look kind of a little bit different.
Yeah, I think looking at galaxies on its like edge on view is really cool, just because you can get a pretty good grasp of how elongated galaxies are, first off, in terms of their galactic center. So it kind of puts it into perspective, just like how much gas and dust are in galaxies, which is really cool. And sometimes that doesn't always translate with looking at it face down. So here it is. This guy. It kind of looks like a flying saucer in the night sky, which is cool. But again, you can just see that really nice, great elongation. So you see that nice bright galactic center where it's just a bunch of light, basically. It looks like a really big fuzzy star. But then you see that line cutting straight through it. And that's all the gas and dust of this galaxy. And where all those gas and dusts are, that's where stars are forming. That's where potential other solar systems are in a completely other galaxy, which is really cool. So all of that stuff would be in just that tiny little plane, that little pancake shaped side, basically. Which is really cool.
I saw that we got a question in the chat from Jar of Sacred Hearts. Jar of Sacred Hearts. I can read. Anyway, they asked if solar eclipses are affected by other planets in any way. And so we're not quite sure what they're asking, but I think I'm going to explain what I'm interpreting it as anyway. So here on Earth, when we are looking at a solar eclipse, because there's going to be a solar eclipse in the far north of the Earth 2 days from now, right, on the 10th. Now, when we look at a solar eclipse, we're going to see the moon obscuring the sun. And many times you'll see the moon completely obscuring the sun. On the 10th, it's only going to partially obscure it because it's not going to be big enough to completely cover it because of the moon's elliptical orbit, and the moon's actually slightly farther away than when you see a total solar eclipse. Now, that is purely coincidental. The moon just happens to be just at the right distance that it appears, for the most part, the same size as the sun in the sky. And we're at a pretty lucky time in the history of our planet for that to even be possible, because the moon is changing distance from us. It's actually going further and further away from the Earth at a point. But now, if you're going to be talking about other planets, we often get occultations. And occultations are going to be when sometimes you'll have a planet like Venus and Mercury pass in front of the sun, and those are going to be called transits. And those are they're even more rare than solar eclipses. The next Venus transit is like 100 years from now or something like that. So they don't happen very common. And if you have a telescope that has a solar filter, you can actually take time to watch the transit. It'll look like a little tiny black dot just passing in front of the sun. So it's not going to be a complete eclipse like what we get with the moon. Now, if you're on another planet, like if you're on Mars or something, you're not going to have the same thing, because Mars's moons are so small. They look like kind of stars in the sky that they wouldn't be able to obscure the sun at all. And I think I would probably have to say that that's the same on other planets as well in the solar system. Is I think here on Earth, we're pretty lucky. We're pretty coincidental with the situation that we have with our moon and sun. If you were on one of the moons of Jupiter, you wouldn't have a situation like that at all.
Yeah, I think that's a good answer to the question. I know it's kind of broad. I think we're gonna go to Vesta first, and then we're gonna go back to another request that was right before it, but we're kind of already prepped for Vesta, so what you might have been seeing on your screen is us putting in coordinates for Vesta, and that's a giant asteroid in the night sky. Vesta's pretty cool. I know one of my colleagues, Hannah, is absolutely obsessed with this, and I think it's awesome because looking at asteroids is something that not a lot of us get to do, like, ever. And so the fact that we can see one is pretty cool. And Vesta is in between, it's in the asteroid belt, which is in between Mars and Jupiter. So it's not like terribly far away from us, I guess, but usually they're pretty small little rocky things. And so they're kind of hard to see, I suppose, in just the general night sky, but it's that nice bright thing right in the center. So it kind of looks like just a star maybe, but you are looking at an asteroid, which is really cool. So kudos to us. That was a good request. I always loved looking at Vesta.
Well, asteroid, the name literally translates to star-like.
Oh, so. True. Sometimes I forget about that. Yeah, there's lots of cool research going on with asteroids right now. I just have to like put in a little plug. We're at least with NASA, they sent a spacecraft called OSIRIS-REx to an asteroid called Bennu, and they took samples from the surface, and they're going to bring them back to Earth, which is totally cool. So we like asteroids a lot, even though they may seem kind of boring at a first glance. We think they're really cool. So yeah. Oh, looks like maybe a couple satellites passed through, maybe.
That was an airplane.
Oh, never mind. Yep, that makes sense with their different colors. Yeah.
Yeah, that was definitely an airplane. It went by way too quickly.
True. Yeah, good point. So we had a request before Vesta, the Leo triplet. So let's go ahead and try to grab. I know at least we can get 2 of them in the field of view with the telescope we're using now. So I think we're going to head to M66 just as a way to find it, and then we should be able to see one. They're kind of be on opposite ends of the screen, but we'll be able to see 2, I believe, with this Leo triplet. So let's see.
So that airplane flying by actually reminded me, earlier tonight in Flagstaff, we had a strange light in the sky. And we were supposed to talk about it at the beginning, and then we forgot. But it did remind me about, we had this strange light in the sky, and then even Claire and I, like, we noticed it when we were outside together, and we're like, what is that? But then it occurred to us pretty quickly that it was actually a weather balloon. Mm-hmm. If you live in Flagstaff and you've been very concerned about this strange light that was just hanging over the western horizon, it was just a weather balloon. And I've been told that our expert in literally everything in the universe, Brian Skiff, who's one of the Lowell staff, he said that it was launched out of New Mexico. So it drifted out over this way.
Yeah. And I know a couple of my colleagues too, specifically one of our volunteers, Lauren. They're really great, but they used their telescope to look at it and took a bunch of awesome pictures. And so we know that's a weather balloon because we got really cool high resolution images basically. And even with my eyes, you could kind of tell that was upside down, like teardrop shape in the night sky. It wasn't like circular or anything like that. So it was kind of cool to see. I haven't really seen one, especially at like almost twilight time. And so it seems like it popped out really well in the night sky because of that. But yeah.
If you have binoculars, they're really easy to see. I remember a couple of years ago, this was a long time ago now. I remember the first time I saw a weather balloon, because this is the closest thing to a UFO I've ever seen. We actually got one of our portable telescopes pointed at, and we had to manually track it so as it moved through the sky. And so you're actually able to see like the whole little parcel that it was holding, and everything was kind of neat.
Nice. Sweet. So it looks like we're just ever so slightly moving the telescope so we can try to get at least 2 galaxies in here to get part of at least the Leo triplet. The Leo triplet is just 3 galaxies together in the night sky that you can, with a wide field binocular or even a telescope, you can see all 3 on one field of view, which is pretty cool. That's not something that you always get to do, especially with such high resolution galaxies like the Leo triplet. You can see some structure with them, which is makes it more interesting, basically. So we're trying to move the telescope just a little bit so that we can hopefully at least get 2. But if not, this is M66, which is part of that triplet. And you can see that it has a nice spiral shape, and there's lots of gas and dust within that galaxy. You can kind of start to see that structure here, which is pretty cool. So yeah, all of that kind of going back and forth. That's just us trying to move the telescope in a way that we can see more cool things, basically. So we call it jogging the telescope. That's like the technical term, I guess.
The one thing that I really like about Leo, so I always call it galaxy season right now. And because in Leo, whenever Leo's up, and Virgo, we have about, I don't know, hundreds and hundreds of galaxies like right between them, which we call the Virgo cluster. And so the springtime, like basically March all the way up until maybe the end of June, we're going to have a lot of galaxies to look at. It's the perfect time. If you look out towards just Leo and Virgo, they're going to cross past the southern sky pretty much in the early evening. So they're going to go ahead and move this over to the other one of the Leo trio, which is M65 there, so we can at least see both of them, even if we can't see them at the same time.
Yeah, let's see. Oh, looks like we need
we got it.
Yeah, one more full exposure at least, but you can definitely see that there's one kind of on the bottom, and then if you see it's kind of like cut off at the top, I think that's the other one, as far as I know. Let's see. Yep. Yeah, there we go. It's barely peeking out, basically.
Now there is a third one called the Hamburger Galaxy, but it's a lot fainter, and it's a little bit too far away from them, so it doesn't show up at the same time with them. It's just barely off the screen for the whole thing, pretty much. Like you move them all the way over to the side to try and get the hamburger, and then hamburger pops in, and these ones are gone.
Yeah.
So
I love the name Hamburger Galaxy, though. Like,
I know, it just makes me hungry.
Right? I agree with that. Yep, so at least, hey, we got 2 in one field of view. That's pretty good. So I know there's a lot more, so let's go ahead and move on to the next object. It looks like the next one is a comet for us. Comet C/2020 T2, or Palomar. It's in the constellation of Boötes in the night sky, so we will be able to get it. We are just putting in the RA and DEC, or basically the coordinates for this object right now, as what you can see is going on with our operator here. So hopefully we'll have that in just a minute or so. So yeah, let's see if there's any other questions. We answered the question about the balloon, which is pretty good. So I know someone mentioned that if it's part of SpaceLink or maybe Starlink is what you meant. No, it's not part of that. Starlink is a whole other mess in the night sky. So sometimes we run into trouble with that. Let's see.
So the Vesta, I think this person was asking if something was in the asteroid belt. Vesta is in the asteroid belt.
Yeah.
So it's somewhere between Mars and Jupiter. I'm not sure which object Mark D was referring to when he asked what kind of telescope we need to see that, because we're seeing a lot of these comets. They were sent in a while ago, and we're just now seeing them. But this particular telescope is a 14-inch telescope. It's a 14-inch reflecting telescope with a long exposure camera on the back of it. But you don't need this kind of setup like at all. Like if I wanted to recommend a telescope like for you to get, if you wanted to like just do some like casual stargazing, I would say an 8-inch Dobsonian telescope is like, honestly, right there. 8-inch Dobsonian telescope, you can see pretty much everything that we've looked at tonight. You just won't get like some of that structure that you need the long exposure for to be able to see them. And you would even be able to see Vesta, even if it looks just like a star.
Yeah. Sweet. So it looks like we have the comet through here. It looks like that more diffuse star right in the center. I believe that's what we're looking at. So that's a nice comet for us. Usually we don't look at comets very often, so it's always kind of fun to see them. Yeah, you can definitely see some of that, just a little bit of that comet. It looks like can't get too much of the tail structure. I don't know exactly what orientation we're looking at this comet, but hey, at least it's one in the night sky. So sweet. let's see what else we have.
Looks like we have Mel 111 or Melot 111. So we can go ahead to that. There's also called the Coma star cluster. So we've actually had 2 people requesting it. So we'll go ahead and go to this. I haven't seen this one.
Yeah, I don't think I have either.
Looks like I've also been informed about the balloon. It was studying the sun, and it was from New Massa. It was from NASA. It came out of New Mexico, and it was to help scientists understand the connection between the Earth and the sun.
That's pretty cool.
Yeah.
I don't know what the connection between.
That sounded really vague.
Yeah. I'm sure they were doing great science. Weather balloons are really helpful for doing things. I remember one of my teachers from 6th grade. She was awesome. She had us somehow we got to launch a weather balloon and do a bunch of cool science. And I remember we put little UV pony beads on this kind of a little stick sticking off of the balloon. And there's also a little Lego man that we put there. So it's our own little astronaut. And we had a little experiment with testing out different sunscreens in space. So it was fun.
That's awesome.
Yeah, I remember doing that. It was cool.
I remember doing that in high school also.
Nice.
We had a science and engineering club that I was in for a little while because I was a nerd way back then. And we launched a weather balloon, and we had we're testing out all of air pressure and temperature and all that. And the instruments did not survive their trip back to Earth. So we did not do a good job with that part of the engineering.
Good learning experience, at least.
Yeah.
So I think we have the cluster through here. As far as I believe, it looks like we've been kind of sitting on this for a while.
Okay.
Yeah. Look, there's a cool, nice bright star kind of down on the bottom. Let's see. It's called the Coma star cluster again. So yeah, it looks like it's a pretty spread out star cluster from what I'm seeing here. But not a bad one. I bet this looks really cool through binoculars or something like that.
I see a galaxy in here actually on the left-hand side. There's a little fuzzy splotch.
Nice.
So we actually have a couple galaxies. The longer exposure help us pick those out. You're not going to see those with your binoculars, unfortunately.
True. Yeah. Oh, that's cool. I didn't notice those until you pointed that out. Basically, anywhere we look, if we look hard enough, we'll see galaxies. Basically, anywhere in the night sky, which is really cool.
Yeah, I think my favorite hobby is to look at deep field views of space to see if I can find galaxies.
Nice. I know we have a request for the Eagle Nebula M16. We might be able to try that at the very end of our streams. It's in the constellation of Sagittarius, and that is still a little low for us right now. It's rising. So we'll try to go back to that at the end, just give it a little more time for that object to rise, and then we can try and grab it for you guys at the end. Let's see. We have a question. Are dimmer stars like brown dwarfs visible at all through your telescope? We think probably. Let's see. I think we can see Barnard's star when it's up. So I think if we can try to go there, since we're kind of on the topic of brown dwarfs, let's try that. So yeah, we should be able to, and we're going to try to go to one now if we can. So we just have to search for it again. It might take a minute or two for that to get through, but I know it looks like we have lots of questions still.
Yeah, I see another one from the Jar of Sacred Hearts asking if we can talk about where Karen or Sharon and Pluto will be during the solar eclipse, and what Pluto retrograde means. So Sharon and Pluto, or Pluto's largest moon, is it's in Sagittarius, and Sagittarius is up at night. So that means that if you have your eclipse glasses and there's a total solar eclipse, you're not gonna see it pop out or anything. Also, Pluto's really far away and really faint, so it's hard to see it all. But yeah, so that's only up at night. So that's not going to be like up during the solar eclipse. And retrograde for any planet refers to its orbit and our perspective of what's happening. So as we watch the planets, you'll see them move through the stars, and over time, they're actually, while the stars rise in the east and they set in the west, and over time, over the course of like months or years, depending on the planet, you'll actually see it kind of migrate backwards through the constellation. I'm saying backwards because like Jupiter started, like it was in Leo and then it was in Virgo. So it's going the opposite direction that like the sky moves. So retrograde means that the planet suddenly appears to switch its direction in the sky. And this happens specifically for planets that are like farther out. You don't see it as well, but it does happen. But what you happen to see is when the Earth, which is going a much faster speed than the outer planets, the Earth will be passing it by because it's just going faster than it. It's kind of like if you're on the highway and you pass a semi and the semi looks like it's going backwards. And that happens all the time because semis are slow. So you can kind of imagine that's what's happening. And so when a planet goes in retrograde, that's basically the Earth passing it up. Yeah. When Mercury goes in retrograde, that's a whole different story because Mercury is an inner planet and it makes an orbit around the sun once every 90 days. Yeah.
So I think we got that star in here. We know it's somewhere in here. It's magnitude 9 star, so it's still like fairly bright. We think it's the one kind of in the center, but we could be slightly wrong. So
I believe it. I believe that.
Yeah. We know that's in there somewhere.
Is the correct one.
Yeah. So there we go for that one. I know we had a couple more quests. We kind of skipped over one for the Iris Nebula. That is much too far north for us to see. So if you were looking forward to that, it is too far north for us. Then we had another request to see the constellation Lyra, which is too big. So this telescope is looking at very small areas of the night sky, like very, very small. And constellations are really, really big. So our telescope is just not good for that, basically. We can't see big, giant things in the night sky, like a whole constellation, which involves many, 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 many stars in it. So we won't be able to see that. We can see things in the constellation of Lyra, just not the actual constellation itself. So I'm getting notification that I think we can do the Eagle Nebula now. So we're gonna try to go there next. It's also called M16. So let's at least try it. And we'll see. The Eagle Nebula is like my favorite object to look at in terms of nebula object. So
I did see that someone requested an object of your choice that will make someone ooh and ah, and like honestly, the Eagle Nebula is the one I would have chosen. So is that cheating, or do I have to come up with a new object?
We'll see if we have time at the end to come up with something of our own. But yeah, the Eagle Nebula is definitely like one of the top on the list for me too. So cool. Okay. So
any of the nebulae that are in Scorpius and Sagittarius, right there in the center of the Milky Way, best.
Yes. And that's because we're basically looking like straight at the center of the Milky Way. So there's just going to be like so much stuff in that area that you'll never get tired of looking in that area, just because there's so much stuff. But here it is. So we're looking at the Eagle Nebula, and this is a giant cloud of hydrogen gas, and we call it a stellar nursery nebula. So this is where baby stars, and I use the term baby very lightly because stars are much more massive than Earth, but these are where they're born in the night sky, in giant clouds like these. And this object specifically has a really cool feature in it that we call the pillars of creation, which are kind of popping in on the left. If you see those like dark pillars of gas, we call those the pillars of creation. And it's a very, very famous picture that the Hubble Space Telescope took. So chances are, if you have like a randomly generated astronomy wallpaper, it's probably the pillars of creation because it's so perfect. So yeah, it's just awesome to look at right through here. I particularly love this one because it shows us how 3D nebulas are in the night sky. Sometimes it can be hard to, especially with the planetary nebulas, where they kind of just like look like flat disks in the night sky, the ones where you're looking at. This one with all of those shadows and stuff really makes it pop out, and it tells us that this is such a massive structure in the night sky, which was really cool. That's like my favorite thing.
I love looking at, so this is what we would call, well, this is what we would call an emission nebula. So it's glowing kind of like a bright pinkish purple color. And that pinkish purple color is primarily hydrogen gas. When we see something glowing purple, we're like, oh yeah, that's hydrogen. But you can also see, because it's obstructed and there's not like this glowing pinkish purple where these pillars of creation are, that's dust. And if anybody at Lowell asks me what my favorite thing in space is, I say it's dust. And so this dust right here is glowing, but again, it's obscuring thousands of stars within it. And it's glowing in an infrared wavelength. So we are human, so we don't have excellent enough vision to see in infrared wavelengths. So it just looks black to us. But if you put something like the Spitzer Space Telescope on it, then all of a sudden, all of these thousands of stars kind of just pop out, because all of those wavelengths that it's glowing in, all the light is now coming through. Infrared wavelengths are big enough to actually go around dust, while visible wavelengths kind of get scattered.
Yeah, that's a cool thing. I always say that, like, if we were snakes, we'd be looking at the night sky very differently than what we do now. It's a really weird animal to choose, or whatever they're categorized as, but yeah, it's just a great object to look at. So I know we have lots more, so let's try to jump ahead. So I know someone asked for M57 again. We might be able to go to it. Let's wait till go to that one if we have time at the end. Like, we can jump to that one again at the end, because I know there's a lot of new objects that we want to look at, and I want to try to get those first. So we have one for M3, it looks like. So we can go ahead and go to that one. I believe this is another globular cluster in the night sky. So we'll be able to look at another firework of stars, basically, which I'm always excited about. So this one isn't as bright as M13, but it's still one of the brighter ones in the night sky, so it should be a nice one to look at. Yeah, right in there. Looks pretty good. So sometimes when we move our telescope while still taking a picture, basically, some of the stars will look like little comets, or kind of like those streaky stars in the night sky. That's what's happening. And usually once we refresh the photograph, they'll go away. But if you see that, that's what's happening, basically. So yeah, here's M3, another great globular cluster. This one looks a little more compact in the center, but it's probably because it's farther away, so nice.
Yeah, I think this one's actually just also smaller in general than the M13.
That's fair. Sweet. So let's go to one called M94, which is a spiral galaxy in Canis Venatici. So that should be good. Let's try that one. M94. Yeah. So it should definitely be up. See what it looks like. It's just not too far away from M3, it looks like. Sweet. So we'll see what this galaxy looks like. It's supposed to be a spiral, so I always like spiral galaxies. And that just means it has a nice spiral structure that we can see, basically. Yeah.
Oh, I've never actually looked at this one, so it's got a very, very bright core, and you can see the arms are still a little bit faint there.
A little faint, but you can kind of tell that they exist, at least. So nice. Yeah, that core is just like incredibly bright, though. I'm very surprised by that. Yeah.
Part of me, I don't know anything about this one. It's a Messier object, but I want to, maybe if someone in the chat knows if this galaxy contains an AGN, or an active galactic nucleus. I studied those a little bit when I was in college, not too much, but AGN are when the black hole at the center of the galaxy is still like accumulating or accreting matter into it. It's still taking in matter, and it's they're usually much brighter than an average galactic core. So our own galaxy, the Milky Way, does not have an AGN. It's typical. So and sometimes these shoot out like radio jets as well. Yeah. But again, I don't know anything about M94. I've never actually bothered to look at it, even though it's one of the Messier objects.
We looked at it once at least for the Messier marathon. That was
I don't think I was there for that.
Yeah. Yeah, nice. So we have a couple more requests. Can we see Phaeton? I think that's how you pronounce it. That's an asteroid. That one's not up for us. It's in the constellation of Aries, which is currently not up for us here. So we won't be able to look at that. And then we have another one for NGC 3147, which is a compact spiral galaxy. And that guy is probably a little bit too north. Our building will be in the way for that. So we won't be able to get that one either. But it looks like the next one that we can definitely go to is the Lagoon Nebula. That looks like the next green one. Green means go for us, basically. So we'll at least head there. And at the end, if we have time, we can go back to some favorites. But I don't know if we'll have time for that. So we'll try at least. But sweet. Just checking to see what questions there are in the chat.
Sure, if you can remind me. So I studied physics in college, but unfortunately I'm a little out of practice because I haven't done physics in a while. I spent a lot of my, all of my time just looking at stars and doing telescope operating and stuff like that. Can you answer this? If photons are massless, then why do they have momentum question? Because I remember learning it, but I don't remember what it is. I don't remember the answer.
Yeah, I don't really have a good answer for either. Like you have mostly been doing astronomy research. I don't think I've even taken a class that has explained this to me in a good detail yet. So I don't think I can answer this in like a satisfying way at least. So I'm sure Wikipedia would do it way better than I could do.
And I'm just over here like, yes, I remember learning that because I remember having a lot of questions about photons that just, I felt like they broke the rules of physics. And then, and that was one of them, is why does it have a momentum? Because momentum, for everyone, just a reminder, momentum is defined as the speed times, or the velocity times the mass. And we have a velocity, but not a mass.
Yeah, very true.
But we do talk about momentum of photons when we're doing physics, but I honestly just don't remember the answer to that.
It's okay. I think we'll survive without a good answer for that. We can at least look at this amazing picture of the Lagoon Nebula. This is honestly like one of the best views I've seen of it, like so far. It looks so detailed and very colorful. So it's a similar nebula to the Eagle Nebula, where it's like a star forming region. So just big lots of hydrogen in here, which is pretty cool. And this is also a really cool one where you can see the 3D structure. You see kind of like that like long pillar right in front that's just obscuring all of that light from behind it. That's really cool. I like this one a lot. It's really big, and I like all the different colors in it, where you can see like more purple and a little bit more blue instead of just like that rosy color from the Eagle Nebula. So yeah, this is a good one. Sweet.
All right. Looks like we're going to do one more object, and it looks like it's going to be the Swan Nebula, or Messier 17. So this will be something that will definitely get the oohs and the ahs in.
Yeah. I think so.
As if we hadn't seen enough really awesome emission nebula. Maybe I'm glad we're ending right now. I can't get my words straight.
Yeah. So while we're heading there, there is one question that I think we can answer. Someone asked, my stellarium shows meteor showers in the southeast. Can you find an active meteor shower? So the thing is that with telescopes, you don't want to use telescopes to look at a meteor shower. You want to use your own eyeballs, because meteors move so fast in the atmosphere that like it would be almost impossible to catch with your own like handheld telescope or like binoculars. They'll kind of just look like something very briefly shooting through. So the best way to see those is just to go outside and enjoy it with your own two eyes. And usually a little after midnight is one of the best times to see meteor showers, pretty across the board. And even if there's not a meteor shower going on, if you just look up at the night sky, chances are you'll see a meteor because we're falling through a bunch of debris all the time. So Earth is getting heavier because we just keep falling through dust in space. That's kind of what's happening. But here's the Swan Nebula. It's kind of upside down for us just based off of the geometry of the mirrors, but it has a distinct swan shape. Oh my gosh, swan shape. So that's pretty cool. I think it's also called the Omega Nebula if you're trying to look it up at your own sky finding app or something. That's another name for it that is pretty popular. But yeah, this is kind of on that trend of similar objects. It's like the Lagoon Nebula where it's a big star forming region. But this one just has a really cool shape and it's a nice one to look at. Yeah, sweet. Oh, that looks so good. You can see all of that gas in there. That's really cool. Sweet. Yeah.
This one is also technically naked eye, sort of. This one and the Lagoon Nebula are visible if you use your averted vision, so your peripheral vision to look, you'll be able to see it just barely right within the realm of human vision. So I encourage you to go out. It's in Sagittarius, I believe. I'm going to confuse this one with another one. But I believe this one is just right above the spout of Sagittarius.
Yeah, I think so too. I think it's not like just above, it's like in that same area though. Just a little bit. Yeah.
Oh, by the way, Sagittarius kind of looks like a teapot. So when I said spout, it's the spout of the teapot.
And it's cool because if you're able to see the Milky Way, or if you see pictures of like Sagittarius with the Milky Way together, the Milky Way kind of looks like steam coming out of the teapot or the spout of the teapot. And so that's kind of a good way to like orient yourself in the night sky. If you can see the Milky Way or if you can see Sagittarius, then you can kind of connect those two together pretty easily. Yeah, I think this is the last object we are going to end on. So I just want to thank you guys all for joining us on this pretty awesome live stream. Again, we were doing this with the Grand Canyon Star Party, so we did it extra long so we could find more cool objects for you guys. And we saw a lot of cool ones that I haven't seen, and so I always enjoy doing that. But I think we're about to wrap it up. So again, thank you so much, and thanks for all the great requests. And yeah, I hope you guys have a good night.
Also, thanks to our telescope operators. They're out there being cold, apparently. So in the middle of June, how dare they? But yeah, so thanks to my telescope operators, John and Sarah, for helping us out with this too.
Yeah, definitely. Cool. Well, yeah, have a good night, guys. Thanks so much.